So you have a fraction, it has to be in brackets. Type that into your calculator. Okay, so we get 10 sine bracket pi divided by 30. Anytime you have a fraction, it needs to go in brackets. Bracket x minus 15. Close that bracket, plus 12. Okay, now, if you're a person who's just randomly guessing as to what your window should be, you stop the madness. You actually know how to easily make your window proper. How do I get the maximum from that equation? D plus amplitude, right? So this is a midline at 12. I go up 10. What's it going to be the highest this Ferris wheel is going to go to? 22. So I'm going to make my Y max be 23 so I can see the top of my Ferris wheel. I'm just going to make sure I'm in radian mode. So I'm going to make my Y max be 23. What's the lowest this Ferris wheel goes at? It has a minimum or a median line at 12 and it goes down 10. What's the highest it goes to? Or the lowest goes to? 2. So basically this Ferris wheel has like a little base of it of 2, right? So I'm going to make it go to 0 so I can just see ground level. And then I'm going to make it go up by 2s each tick, okay? Now, most people okay with that. Then they don't know what the heck to make their x-mins. Well, my x-min's going to be 0 because it's time. I'm going to start at 0. I'm not going to start at negative time. Doesn't make sense. But what do I make it the max be? Well, I need to know how long it takes to rotate because I want to see at least 2 or 3 rotations of this Ferris wheel. Okay? How can I figure out how long it takes to rotate? 1 revolution. What is 1 revolution the same as? Period. How do I get a period off an equation? 2 pi divided by b. So 1 revolution equals 2 pi divided by b. b in this case is pi over 30. So that's 2 pi times 30 over pi. So this thing repeats itself every 60. So if you have it at 10, it's going to be too small. If you have it at like 4,000, it's ridiculous. Okay? We need to make it kind of realistic. So we, from our equation, can instantly get information to draw this properly. I want to have 3 revolutions. It revolves every 60. So I'm going to put it at 180. And then I'm going to make it go up by 45, sure. And look, I have a graph. It's not wonky. It's not crazy. It's not this tiny. It's not like you see a little piece of the line. It's not 5,000 of them. Okay? With giving ourselves 2 minutes max, we put a proper window and could see this. It's in radian mode. Then go to your window and make your X resolution be 2. It's just drawing it too fast. If your X res for a lot of them is past 2, it draws it too fast, then it doesn't get the actual curve properly. Okay. I think you have drawings in the background, so I reset it. I have to type it back in. Okay, so this one here, let's go like this. This says h of t is the height of the rider after t seconds, okay? So this is the catch here. We have to read what the stuff is. So h of t, or y, is the height of the rider after t seconds. Okay? So t is time, which is x. Height is y. Okay? So here it says, what are the maximum and minimum heights of the wheel? We figured that out. What were they? D plus amplitude, D minus amplitude. So this one would be 12 plus 10, which is 22. This one would be 12 minus 10, which was 2. So that was our max, and that was our min. This one says, how long after the wheel is at its lowest point does it reach its highest point? How can we figure that out? How long after it reaches from its lowest point does it reach its highest point? Half the period. Yeah. Because we start at our lowest point. To get to our highest point is half the period, then we go back to our lowest point, right? So how long did it take us? It took us 60 to do the whole thing. So how long is it going to take us to reach the maximum? 30 seconds. How long did it take it to make one revolution? During 1 minute of the ride, 1 minute of the ride, 1 minute is the same as what? So basically during one revolution. At what times after the rider got on its wheel at a height of 20? So did they give us the y or x? Is 20 y or x? Okay, that is a key thing. If you can figure out if it's x or y, any answers after that are really easy. So 20 meters, we know they gave us y. So they're telling us that y equals 20. Correct? Where's the only place we can type in y equals? It's not a trick question. The y equals. So do not take out y1. y1, you have the equation typed in. If you take the equation out and put in 20 for it, you have no equation left. That's not going to work. So you're going to put it into y2. So into y2, we're going to put in 20. So if ever they give us y, we type y2 equals 20, and then press graph. Okay? So it crosses a whole bunch of times, right? This one says, at what times after the rider got on the wheel? In the first revolution, because it says in the first minute, during 1 minute of the ride. So we need to find this spot and this spot. What do we have to look for? Where they intersect. Should we ever use the trace button?
Yes.
No, the trace button should be burnt off your calculator. I hate the trace button. I wish it never existed. The trace button leads you guys to trace to it, and they get the wrong numeric response because it's not accurate enough, and you get like 4.5, and the answer is actually 4.6, and you get a numeric response wrong. I wish I could burn the trace button off your calculator. Like, I would love to just burn off. But behind it's calc, and I like that button, so I can't burn off the trace button. I would like to rub it off so you didn't know it existed. That would be like, I'd like to take some.
Just put the cal.
If I had a dream, if I had a dream and it worked for me, these would be swapped, and then the trace would be just erased off. Like calc would be this button, trace would be behind it, and it would be just, it wouldn't be there. It'd be gone. Should be gone. Okay? So second, calc, because then we wouldn't have to do that. We just go calc, right? Right? Intersect. I'm hit number 5. And then we need to be near it. Now, pay attention. I didn't know this. For some reason, I'm pretty stupid in high school. Yeah. So I would like hold this and I'd be like, come on, why are you taking so long? I'd be so angry at myself. When really, you can be on either line, right? Yeah? So if you just go arrow up, it'll pop you onto that other line. And then shorter distance gets you there faster. If you don't know that, I'd be like, come on, let's go. Don't got time for this. I'm writing a test. But I could just went, and And then I've been there. Oh, life-saving skills. Okay, so get over there, hit enter. Which do I take? The x, because I want the time, right? So 23.9 seconds would be the one. And then the other one, so second, trace 5, because we're trying to find another intersection. And look, it's on that stupid graph again, but I could just arrow up, pop it up there. Good times. Get it close to this one. Enter, enter, enter. For those of you that are spending 20 times trying to find the first curve and the second curve, just press that enter button. Don't waste your time. You ain't got time for that. So 36.1. Okay? Good? Great? Lovely? Now, what happens, before I get all, yeah. So what happens if I gave you one other thing? So I gave you the y and asked you for the x. What if I said, what was the height at 10 seconds? So now I gave you the x. When I give you the x, where's the only place you can put x in? Yeah. Second, trace, because I want to calculate value. So whenever you're given the x, so you're given x equals 10, because time is x, you're going to do second, trace, number one value. So second, trace, value, and it gives you x equals. And what does x equal? 10. And then we just sit there and hope to goodness that it moves on. Or what can we do? Hit enter. So 7. Why is there only one answer for that one, but there was 2 or a bajillion actually for the other one? Why does that happen? Why do I only get 1? Right. There's only one time that equals 10. But a height, it cuts across the graph at a horizontal, right? So it's going to cross in a whole bunch of spots. Okay? All right. So we're going to go to this one, example 3. So you are going to be given this question here. You're not going to be given any of the rest of this, but this is what you are going to do. You're going to draw yourself a circle. You're going to sketch it, and then you're going to sketch the graph. Okay? Tuesday. Okay. So a Ferris wheel with a radius of 10 meters. It rotates every 40 seconds. Passengers get on the bottom at 1 meter. Okay, I'm drawing a base because they get on the bottom at 1 meter, right? So here's the base of my Ferris wheel. Here's the ground. I promise you, you need to do this every time. So you need to draw the circle, draw your Ferris wheel, and then you guys, you need to split it into 4. Because we're going to get a point here, and a point here, and a point here, and a point here. We're going to get 4 points. Why do we need those 4 points? Because this is the minimum. This is going to give me where cos has a horizontal translation, right? The maximum is going to give me where positive cos has a horizontal translation. This is on the way up, so positive slope. This is going to give me where positive sine C value is. This is going to give me where negative sine C value is. So every single one of these little intersection points here gives me the C value for cos or sine. This is for negative cos, positive sine, negative sine. If you draw this, you have your C values. Okay, because this is on the way up, meeting at the midline. This is on the way down, meeting at the midline. These are my sine phase shifts. These are my cos phase shifts, the min and max, right? The x values of those. So This is what I do every single time. I follow the same steps because I'm a consistent person. If I stay consistent, I do not mess up steps. So first thing I do, draw myself a circle, draw myself a little base if it has a base. If it's a tire, it's probably not off the ground, so it would be on the ground. It can happen. It could be a Ferris wheel on the ground too. If it was like a gondola type, right? If they went around and didn't break your legs off, that's fine. And then I draw my ground. And then I draw my little 4 splits. And then I go around and do my heights first. Okay? So this graph starts at a height of what? 1. Height is x or y? Y. So this one starts at 1 meter? Yes. Okay. What about this point here? It has a radius of 10. So what height is this going to be? A whole bunch of people always say 10, but that's not right. It's 11. Why? Because you have to add this little 1. So what do? I label it. This is 1 meter here. So that's 1. And this is 10. And then this is 10 so that I don't screw up. So I start adding from the ground, right? So I go up 1 and up 10 more. So this is actually at a 11 meters. And then they mess this one up too because they'll say 20. But this one actually isn't at 20. It's at 1 and 10 and 10. So 21. And then this one is at what? 11 again. And then this one comes back down to 1. Now I need the time, the x values. So this one starts at 0 seconds because they get on the Ferris wheel at the bottom. It says, suppose you get on at the bottom. And they'll clarify that on your diploma because just in case you got on like a lift and got on somewhere else. Now, it rotates every 40 seconds. So I know that this is also going to be 40 because it's going to come back down to here. Those ones are easy. How in the heck do I get the other ones? The top one's easy. What's the top one going to be? 20. What's this one going to be? 10. What's this one going to be? 30. If they're hard to figure out, you guys, you could always divide your rotation by 4, right? And then it's just going to add that because 40 divided by 4 is 10. So 10, then 20, then 30, then 40. Now, if I wanted to, I could sketch it. So I'm going to have 10, 20, 30, 40, time in seconds. And then I'm going to have 1, and I'm going to have 10, and I'm going to have 20. And I'm going to draw them directly across. See? 1, 10, 20. And this is height in meters. So I start at 0, 1. Then I go to 10 and 10. 10 and 11. Bad math. 11 and 21, guys. 11 and 21, not 10. So at 10 and 11, 20 and 21, these are 1s. 30 and back down to 11, 40 and up to 1. And pretend that that's actually drawn properly because that's not very symmetrical. It should be over here. Okay, and we have 1 revolution. We're going to write an equation as time elapses. So I'm going to write all 4. So y equals, what's my amplitude? What's my A? It's the radius. Remember? Amplitude, radius, same thing. So plus 10, minus 10, plus 10, minus 10, sine, cos, cos. Okay. Remember for sine, we could draw the midline if we want. Where it intersects is here and there. This one is going up. This one is going down. That's why this is the positive sign. This is the negative sign. So positive sign, I moved over 10, right? Which is this first one, 10. So I'm going to have x with a space. Can you tell me b here first? Minus 10. For a negative sign, it's going to be 30. So I'm going to have x minus 30. For positive cos, it's where my max is at. So it's at 20, right? So x minus 20. And then this is just going to be x, or x plus 10, or x plus 0, I mean, sorry. How do I get my b value? This is a 30, this is a 20. How do I get my b value? Two pi over period. And the period was how much? 40. So it's pi over 20. What's my d? D and center are interchangeable, right? So what's the center at? They will have center at 10 as an option. Absolutely. Right? Because you're going to get the little one. Now, are any of these more correct than the others? No. All four of them make that graph. So to answer any of the questions below, I have two questions below. I'm going to put in the easiest one because any of those four get me the graph. So I'm going to put this one into my calculator. And I'm going to check and see if it looks the same. So I'm going to go negative 10 cos pi over 20 in brackets because it's a fraction. X plus 11. Go to my window. It repeats every 40. So I'm going to make this be 120 now. That'll give me 3 revolutions. I'm going to make this be 40. My max height was 21, and so it'll still work. 0 and 23, right? And the first graph. Our other window actually would have worked just fine. And now we can answer any questions it has. So this one says, find the height above the ground at 15 seconds. The hardest thing for us is to decide, did it give us X or did it give us Y? X. Where's the only place we can put in an X? Value. So second, trace, value, 15. If you wanted to, could you just punch it in for X here in the equation? Go like negative 10 cos pi over 20 times 15 plus 11? Yeah, good. A lot of people find the calculator easier though, because they're not sure where to put brackets and stuff like that. But you could just put that into your main screen and get an answer, and it would be the same. Then this one says, find your times when your height is 15 meters above the ground. Well, they couldn't say find the times. I'm going to say find the first 3. Find the first 3 times. So 15 meters is Y2. So we're trying to find the first 3 times. This one, and that one. Second trace, 5.